Hello students, today we will estimate the error in connection with Newton-Raphson method. Okay, so see what I need to do is, first of all I have written here, let beta be the root of my equation. Okay, fx is equal to 0. Fine, so if beta is the root, then my f beta is 0. Fine. Next, before going into the derivation part, let us see some symbols. Okay, here it is epsilon, right? Epsilon n is equal to beta minus xn. What is xn? In our analogy, think this one as your destination, that is a RCCIIT, right? And you have reached from Jharkhand to CIT Moore, right? Still you are lagging behind by some distance. How much is that? That is what I called epsilon n. Okay, so this is basically the error occurred in the nth step. Fine. And xn is basically the value of x at the nth step. Nth means the nth iteration. Fine. So this one is epsilon n. Then I have written epsilon n plus 1. This one means now from CIT Moore I have reached Garment Park. Okay. Still I haven't reached RCCIT. It is small distance between these two, Garment Park and RCCIT. So how much is that? This is your epsilon n plus 1. Okay, so I hope the symbols are now clear. Now let's come to the derivation part. So you know this, if beta will be 0 since beta is the root. Now beta can be written as xn plus this error in the nth step. That means CIT Moore plus this distance, extra distance. If I cover, then I will reach RCCIT. Okay, so this one is from this equation. Fine. Then equal to 0. Now again this type of problem, in this type of situation, what do? We generally expand by Taylor's theorem. Okay, so it will be fxn plus beta n f dash xn plus epsilon n square by 2 f double dash xn plus the other terms, rest of the terms. Fine. Now what we have done here is we are dividing both sides by f dash xn. Fine. So what we will get? Fxn by f dash xn. This f dash xn will vanish, and this one there will be f dash xn in the denominator, and I am neglecting the other terms. Other terms I am neglecting. Okay, since this one is very small, this epsilon n is very small. Now see, from Newton-Raphson method we know this. This is the basic formula. Now this part, only this part, here I can replace by this one. I can write xn plus 1 minus xn is basically minus of this ratio. Now from this point, I have replaced this ratio by this one. Okay. Now what is xn plus 1? What is xn plus 1? Xn plus 1 is basically this. I can write it from here. Beta minus epsilon n plus 1. Beta minus epsilon n plus 1 minus this xn can be written from here. It is beta minus epsilon n. Fine. Now if you solve this epsilon n, this will be plus, right? Minus plus, and this will cancel out this one. So ultimately we will get this much. So if I write this error in the n plus 1 step, it will be this much. Okay. Now see, f double dash xn, this is basically constant, right? 2 is constant. F dash xn, this is also a constant. So I am replacing this whole part by another constant, sec. Okay. Sec. So what is basically this, the error in the n plus step is practically proportional to the error in the n step, right? So as we proceed, my error is having a quadratic relationship. Fine. So we can write it that the error in the n step can be written as it is the second order of quadratic convergence. Convergence means we are approaching to the accurate value. Okay, second order of quadratic convergence. Okay, in the exam they might ask what is the order of quadratic convergence in Newton-Raphson method. You said you have to write 2. 2 will be the answer. Okay, so this is how we can estimate the error in Newton-Raphson method. Fine. So in the next class we will be learning more methods. Newton-Raphson method, you need to solve the problems, numerical problems and the derivations which I have done. Okay, this formula and this, you need to know this error. Okay, how the error is propagating if I proceed from one step to another in Newton-Raphson method. Okay, fine. Okay, this much for today. Stay safe. Thank you.